Hey everybody, Charles from GMAT Ninja here. Welcome to hour number 9 of our nonstop GMAT crash course marathon, 24 hours straight to benefit charities working with Ukrainian refugees. This hour, my job is to talk about Quant again, and I was lazy and left my sentence correction on the board. So goal of all of these sessions, we're talking about not just the foundations. If you want foundations, great foundation series done by guys that are smarter than me at GMAT Ninja. Branson and Harry doing great foundations of word problems and algebra and exponents and geometry. Not doing that. I'm trying to get at the things that most people do wrong of any level. So you might be pretty advanced, you might be kind of semi-advanced, you might be really struggling. But what are the things that everybody kind of has in common when they do quant? What are the things that people tend to do wrong? This lesson is going to be on scary symbols, walls of words, things that intimidate you. One of the things we see quite a bit is you see an unfamiliar symbol, an unfamiliar phrase, and people kind of freak out, even if they're pretty good, or they start lunging at stuff. And we're going to give some examples today that are basically going to get at the idea of be systematic, follow your process in a nice, clean way. You're not going to get yourself into trouble. Same idea on super long word problems. As I get the question all the time in the forums, even in the verbal forums, hey, what do I do in these really long quant problems? I'm going to give you some super long quant problems. And the goal is just to get you breaking things down really, really cleanly. A little bit of a companion to what we were talking about earlier with percents and interest rates. If you get the chance to be literal and translate cleanly, by all means, absolutely do it. All right, let's get to some math. Again, I'm not going to melt your face off with difficulty in this. I just want to get you not intimidated, being really clean and systematic, even when something's long or scary looking. Not going to be the hardest session we're going to do today, I don't think. And here we go. Okay, coming back. Again, I'm not going to melt your face off with this lesson. It's more just kind of getting your mind right. So a lot of people look at this and go, it's a whole paragraph, and they kind of freak out. And it's just keep your information organized, keep your information organized. Thank you so much. Now I'm hearing people kind of chiming in and saying they're struggling. So it's really easy to kind of try to do too much on this, and you kind of swallow it whole. One of the things I've kind of used in a bunch of different contexts so far today. Take it one little chunk at a time. So all we're doing is we're combining ratios. If I organize my information nicely, it shouldn't be too bad. So I can do this in kind of any order. If I'm being super enterprising about it, maybe there's certainly are better ways and worse ways. I'm an hour number 9, so I might not even pick the best way here. But all right, I'm trying to get to first and third into the same ratio. The first thing that kind of jumps to mind here is, well, I can equate kind of second and third through fourth. I can get to first and fourth through second. Okay, let me just start kind of combining some of these ratios, and let's see where that gets me to. So first, second, third, fourth, first to second, 3 to 4, second to fourth, 8 to 5, just lining up my information till I can, as somebody just said in the live group, keeping it clean and hygienic. Very well put. So, okay, ratio of 3 to 4. So I would like kind of that second. It's kind of like a least common multiple sort of concept there, where if I can get these ratios kind of scaled up or scaled down or whatever I need to do to get this number to match, then I can kind of equate it. If this ratio were 3 to 8, then I could say, okay, well, 3 to 8 to 5. So all I really need to do here is multiply this entire ratio by 2. 3 to 4, that's the same exact thing as 6 to 8. Great. Now I've got my 6 to 8 to 5. Wonderful. Now I need to get my third grade in here. So I've got 3 to 2 for third to fourth. Same deal. All I have to do is take this. I'm going to multiply it by 5. So I get 10 here. I get 15 here. And I'll do the same thing with this guy. Multiply it by 2. 12, 16, 10. Nothing fancy. Nothing too technical. Just keep your information really organized. Take a breath. Read carefully. And now, broken record. And that's it. I got my ratio of everything, and I can answer whatever the question is. What do we want first to third? 12 to 15, we can reduce that, divide both by 3, and we get 4 to 5. And that's it. These questions where you look at it, wall of text, funny symbols, take a breath, be methodical, translate what can be translated. Don't panic. I know it sounds really silly. Every GMAT question meant to be doable in 2 minutes or less if you find the best way. Hard to do. You're not going to do it 100% of the time, but it's probably there. Don't get intimidated. All right. Let's do one more. When you get a question like this that I look at, hey, part of what's going to happen here, hour number 9 straight without a break, really, even though obviously I've seen this question before, I selected it. But I look at it and I'm glazing over, right? Just like some of you guys are, might be for a different reason, but I'm looking at it and going, oh, wow, I got to read this 6 times. What's happening here? Now, for me, 20 something years of GMAT under my belt, yeah, it's the sleep coming through there. My memory's shot by hour number 9 going straight here. But that's kind of a similar feeling if you've never seen it before and you struggle to break this stuff down. So what do you do? I mean, I feel like I'm seeing some of the comments in here where it's like, oh, my brain scrambled, I don't know what to do first. That's how I feel right now too, to be honest with you. And so I'm just going to be super methodical. Like this is going to sound kind of weird. Like I want to kind of get a visceral feel for my math sometimes. And sometimes just writing stuff down until it makes sense to me really, really helps. And this isn't me being gimmicky teacher guy. This is me being brain dead guy who's legitimately struggling on this right now because my brain is out sauce. So I got John, I got Mary. What do I know? So we'll say their starting pay. So it says they each got paid X dollars in advance. Cool. John worked the job for 10 hours. Mary worked for 2 hours less than John. Okay, so hours, 10 and 8. Where am I going with this? I don't know yet. But that's kind of the point. Okay, I'm starting to make sense of it. I've kind of already, I'm halfway through. I've got something here. Mary gave John Y dollars of her payment so that they would have received the same hourly wage. Okay, I'm going to stop there. Sentence is getting too long for my scrambled little brain. Mary gives John Y dollars. Okay, so we'll say ending pay. John's getting X plus Y. Mary's getting X minus Y. I still haven't done anything yet, but at least I'm being methodical. And I've got something maybe coming. So if they would have received the same hourly wage. Okay, well, what's an hourly wage? This is going to sound really silly, but these are the things that bail you out of these questions that feel complicated. What's my hourly wage? It's my total pay divided by the hours worked. That's it. So total pay. Hours worked. Now I'm basically done, right? Here's my total pay, X plus Y, or John's total pay, hours worked. Mary, total pay, hours worked. They're equal. Now all I have to do is just do a little bit of algebra thing that I'm not sure I can still do at this hour. It's not even that late, but 9 hours straight. My algebra is bad. Yell at me if I make a mistake. 8x plus 8y equals 10x minus 10y. And we're solving for x is all we're doing here. So I'm going to add 10y to both sides. I got 18y over here. We get 2x over here. X is equal to 9y. That's it. So bottom line here, it's that intimidation. So are you getting scared and kind of starting to get squirrely and you do crazy stuff or you're kind of paralyzed because you're trying to do all bits at once? Took it one phrase at a time. That's it. Once you do that, none of the math is super hard. Anchor yourself in the concepts. Keep your information nice and clean. And it's not so bad. All right. I think I'm going to veer back and forth a little bit between walls of words and funny symbols. We're going to go funny symbols next. Okay. Really easy to look at this and kind of go, well, I've never seen that symbol before. GMAT's going to give you the instructions. That's their deal. And this hurts my brain. And again, I'm not playing. I'm not playing dumb. I'm not playing like, oh, well, I'm pretending to be a struggling student. No, I've been standing up here for 9 hours now. Greatest integer less than or equal to 0. There's greatest, less and equal to all in the same phrase. I don't know what's happening here. So take a moment, like if you're having that experience, either because this kind of thing intimidates you, or because you struggle a little bit with the reading, or because you're tired, or because you're seeing this on an exam and the time pressure is getting to you, all of those feelings are normal. They kind of all feel the same, right? For whatever reason, we don't have the clarity of thought. Take a moment, come up with examples, maybe, whatever you need to do to kind of get your head around it. Here I'm saying greatest integer less than or equal to x. Okay, so if, for example, this is 2.5 inside there, I want the biggest thing that's less than or equal to it. Oh, okay, I'm rounding down. That's it. Now I got it. So if it's 2.5, this is going to be equal to 2. Oh, okay, not so bad. That's the greatest integer that's less than or equal to x. If this is 2, then inside the little brackety thingies, still 2. All right, cool. Not so bad. So I'm going to start with the positive ones here because negative numbers increasingly hurt my brain at this hour. It's not even that late. It's 5 o'clock here, but yeah, brain. 2.7. Well, this is just 2. 3.4, that's 3. I'm rounding down. This is -1. Anybody else make that mistake? Really easy on the negative to say I want the greatest integer less than or equal to x. I'm just kind of lopping off the decimal bit. Not the case here. You need to go for the next number down, which isn't -1, it's -2. Add these guys up. Hopefully you get 3, and that's it. Okay. Next one. Again, I'm going to veer back and forth a little bit between the walls of words and the allegedly scary symbols. Here's a wall of words. All right. Not seeing much disagreement here. I'm not sure if it's because the people who are struggling with it are just paralyzed, not saying anything. But again, classic question where you might look at this and go, it's really long. It's 50 words long. Oh, super scary. Fair enough, right? I mean, I get intimidated by it too. I get lazy about reading it, frankly. But not so bad here. So amount that you invest doubles in approximately 70 over our years. If you're fortunate enough to have studied, maybe economics or finance or worked in finance, you might already know something like that, 72, 73, depending on the framing of that rule. Doesn't really matter though, even if you've never seen it before. Classic GMAT question, follow their instructions, you'll be all right. So what are we saying? The interest rate in this case is 8. So how often does it double? Approximately. It's my favorite word. 7 divided by 8, 9-ish. About 9 years to double. Well, that's convenient. So in 18 years, what happens? Well, it doubles twice. So it starts at 5,000. Kind of mistake I might make here is it doubles twice, so it triples. That's not true. Doubling twice means I multiply it by 2 and by 2 again. And again, one of the things, it comes up a lot, right, is it's like, well, the people who do really well on this test don't make mistakes like that. Don't do dumb things like 5,000 times 3 in this case. Yeah, people with really great scores do that. They just catch them, right? So I am sloppier than probably 80% of you watching this. Part of how I kind of got into tutoring, actually, in a way, or part of what appealed to me about teaching, or where I thought it's something to add value was I am naturally very, very sloppy with my math. But what's always going on in my head is that as soon as I do something, I'm checking it again. I'm trying to look at it from a different angle. And because I was such a sloppy mess as a kid, I kind of trained myself to do that. That's what I want you guys to do. If you're catching yourself, if you notice you're making a lot of sloppy errors, how do you reprogram yourself so that every little step you take, instead of multiplying this by 3, I'm thinking, no, wait, is that right? Is that right? Is that, no, doubling twice. What does that mean? It means times 4. Answer is 20,000. So answer choice A. So don't be ashamed if you make those silly errors. The question is just train yourself to catch them before you move on. All right, back to funny symbols. Okay, this is great. So again, I think what's happening is that there's a handful of people who are getting this right away, and I think a whole lot of people are struggling, and a few that are being vocal about it. And I really appreciate the vocal ones who are struggling. This feels really opaque, right? I think even more so than the previous examples we've had, where it's like, wait. What do we mean by a to the k? Because this is abstract, right? Like a to the k is divisor of b. I can't really get my head instantly around like what that would mean. What do you mean that some integer raised to some integer power, all positive integers, is a divisor of some other integer? Like that hurts. But then what does that mean? It means the next higher power of that thing is not. Okay, maybe I'm getting somewhere here, but it's abstract when you look at it at first until you kind of try to put some meat on it. Interesting misreading going on too. So what we're asking for is k, this exponent. So what does this mean? What we can do is we can take this, maybe the best thing to do is just to be super organized, a little bit kind of almost mechanical at first, and just translate as literally as you can and just say, well, okay, maybe I don't understand really what's happening here. But maybe I can kind of write this out in this form, kind of punch it into sort of what this definition of the symbol is, and see if that helps the light to turn on. So we're saying that 2 to the k is a divisor of 72, but 2 to the k plus 1 is not. Now, a couple reasons you might struggle here. One is just getting intimidated. Another is you might be kind of misreading in some way, and I saw a little bit of that in the live group. Another might be that you're not super clear on number properties and kind of the divisibility stuff. We're going to talk about that in a couple hours here. Have an hour on remainders and divisibility. 2 to the k is a divisor of 72. A bunch of ways you can handle that. Some people will just kind of take this and automatically prime factorize it. So this is 8 times 9, 2 to the third times 3 squared. So if 2 to the k is a divisor of this thing, so 72 has 3 2's in it. And again, I'm not going to go over the basics of this right now. Hopefully this makes sense to some degree. So 2 to the k is a divisor of this. It means that we could have up to 3 2's. So k could be 3 here. K to the k plus 1 is not. Okay, well, great. That fits. That k has to be 3. Another way you could frame this to help you kind of think about it, okay, and we'll get into this in a couple hours. If 2 to the k is a divisor of 72, what we're saying is that 72 divided by this gives you an integer. If this helps you, go for it. And then you can kind of see that this is 2 to the third times 3 squared. Prime factorize it again. If this helps you to see what's going on in terms of the number properties, that's fantastic as well. So what we're saying is that if this is an integer, that 2 to the k has to get canceled out. We're looking for the biggest number where this would happen. So once again, k has to be 3. I know I'm whipping through kind of the number properties divisibility portion of this pretty quickly. If this is something that's really uncomfortable for you and you're like, whoa, divisors, remainders, multiples. Again, we're going to cover that for an hour up ahead here. Also on the GMAT Ninja YouTube channel. Once again, Harry did a fantastic job with that, really kind of breaking down the basics. 2 videos on number properties, good for beginners, good for intermediate folks, a little bit of challenges for the advanced folks. So if you need the remedial stuff, go see Harry do a number properties over there on our channel. Okay, so there you go, answers 3. One mistake I saw people making that I thought was really, really interesting and not uncommon at all is here's your answer choices. And we have 2, 3, 4, 8, 18. And we had somebody who commented, and I really appreciate the honesty on this, that all of these are divisors of 72, so WTF, right, but we're interested in k. The answer is k, which is 2 raised to these powers. 2 to the power of 18 is not a divisor of 72. 2 to the 8th is not a divisor of 72. Neither is 2 to the 4th. 2 to the 3, 2 to the third and 2 squared is, we're looking for the biggest one. So your answer is going to be B here. All right. Let's do one more. How much time do we have? We have 20 minutes. Outstanding. This next one from the legend himself. This next one's from Benuel. Engineer's disease, one of my big themes for our math lessons today. Really, really easy to get super algebraic here. And we're going to have to ask Benuel later. Did he mean to make this spell out flaw? Was that kind of an embedded joke or was it kind of random? I'm not sure. I'm guessing it was kind of a joke, but who knows? All right. So we know that, what are the names again? Fritz, Franz, Fritz owns 2/3 the number of all the other guys put together. Now I can do this. What's the other guy? Luis. 3/7 of all the other people put together. Alfred is 4/11 of all the other people put together. F plus L plus W. And now you're sitting here looking at this and going, well, all right, cool, man. I got a system of 3 equations with 4 variables. Party on, Wayne. This is fantastic. So when I talk about kind of those 4 steps that everyone's probably tired of hearing of if you've watched any of our quant content, where I say, okay, read twice, plot your path, check your work, et cetera, read again, be careful, watch your back, be honest if you're making silly mistakes, work on this so you stop making them. Right here, so I started down one path here. Hey, I'm in trouble. What am I doing? Am I going to keep bashing my head against this wall forever? Now, so I got 2 choices here. I got 3 choices. One of them's a terrible idea. Choice number 1, I fight this algebra into the ground. I'm going to be miserable. Why do that? Time test. Not going to do it. Horrible mistake. Worst thing you possibly do is get stubborn here. Well, it's just algebra. I'm going to battle into the ground. Look, you're not going to get all 31 questions right. Or if you are, you probably shouldn't be watching this because you don't need this. You're going to struggle on some of them. If this happens to you in real life and you don't see another way, walk away. Don't battle this into the ground. Going to kill you. Option number 2, walk away. Perfectly good option. Option number 3, Give another 30 seconds, see if you can find a better way. My algebra is not working here, so I'm going to take a step back and go, can I intuit something that's going to help me? Hard to see here, but if I can see it, maybe I've got some hope because the algebra is not getting me anywhere. Maybe somebody who's better than me at algebra or more patient or more well-rested can find it. I don't see it. I'm going to think of this a different way. You know, if this said that Fritz has 2/3 of the total, it would help me to get my head around it a little bit, right? Like that would feel more intuitive to me. But I can kind of use that to my advantage here a little bit. That kind of thinking and say, well, if he has 2/3 of what those guys have, it's kind of like saying, well, wait a minute, they have combined, these guys have 3 parts and he has 2. So they have 3 parts, he has 2. So for example, just to get at kind of the underlying math of what's going on and try to get some intuition, it's kind of like saying these guys put together, let me get a different color out. It would work to say these guys have, you know, $3 or 3 parts and he has 2 parts for $2, however you want to think about it. Wait, okay. So now I can start to say, here's the fraction that Fritz has of the total. Because I know that these guys have 3 parts, he has 2 parts. So now we can say Fritz has 2 parts of the total 5 parts. He's got 2/5 of the total. And we can keep doing that. What's this saying about Luis? Luis has 3 parts. These dudes have 7 parts. So what does Luis has? He has 3 of the total 10. So 7 parts here, 3 parts there. Luis has 3/10 of the total. Turn that into a T. I don't really need the T, but I'll go with it for now. Alfred, same idea. These guys, 11 parts. Alfred's got 4. Alfred's got 4/11 of the total. Well, now I can just add all these puppies up. I'm sorry, I messed that up. 4/15. My bad. All I have to do is add these up. Very nicely done. So nice little thing that Buñuel put in here. I do think it's a fantastic question, by the way. Another little nugget that Buñuel put in here in the GMAT club test that I think is a really nice little thing is in adding up these 3 fractions, you could go into autopilot and get a really big common denominator and say, well, okay, 15 times 10 times 5, the common denominator is 150. Nice little detail. I'm guessing it was deliberate. My best common denominator here is actually 15. So great. So I've got 2/5 plus 3/10 plus 4/15. This is going to tell me the total that the other guys have. So this is 12/30 plus 9/30 plus 8/30, 17 plus 12, 29/30. Okay, so these guys have 29 of the 30 parts. The other dude, I forgot his name now, Werner. Great name. That's what we want. We don't know how much Werner got. Werner's got 1/30 of the total. The total is this. And all we have to do is do a little bit of math here. We got it. Divide this by 3. 1.2 million. Lop off a 0. 120,000. And the answer here is C. So congrats to the 3 people out of the 100 and something watching live that got that right, one of whom is a tutor. Okay, one last question. What do I want to do here? Let's talk about our guy, Henry. Another one of those classic, 3rd or 4th one we've done here. Funny symbol. Don't get scared by it. Anchor yourself to whatever you can. If there's a way for you to translate this in a way that makes it more intuitive, that's the game, right? That's how algebra is really too, right? Is how do you rearrange things until something that you can get your head around starts to emerge from it. You isolate the thing of interest. Kind of same deal here. That's the skill they're kind of testing you on is, can you look at this, follow the instructions, make sense of it intuitively? None of this is going to be super advanced math. I can pretty much guarantee GMAT's not going to have any symbols that you need to know that you haven't already learned. It's just not what they do. All right, so this thingy, brackety thing, n, denotes the product of integers from 1 to n inclusive. That's a fancy way of saying n factorial. So that's one bit of demystification, right? 1 times 2 times 3 times 4 all the way up to n. Great, that's just a factorial. So now I can translate this. And so I wonder how many primes are between 6 factorial plus 2 and 6 factorial plus 6. I did see somebody, one of my favorite people, in fact, in the live group, who I think multiplied all this out and got 722 maybe here or something like that. That should be setting off alarm bells in your head, probably, unless your arithmetic is so spectacular that that is not a big deal to you. and you're so good that you can kind of look at this and figure out whether it's prime automatically. If that's the case for you, awesome. For most people, should be some alarm bells in your head that maybe you're doing something that's harder than it needs to be. You can probably get through it. So that's 722, and this is 726, I believe, and we're inclusive. So are we serious? Am I going to sit here and try to figure out whether each of these numbers is prime? And I shortcut the arithmetic here, 6 factorial. That's rough, man. Like, I can tell that, like, okay, that's not prime. That's not prime. I don't know about that. That's a multiple of 2, so not prime. I guess maybe it's not so bad. I mean, I just have to investigate 723, figure that one out. Multiple of 3, you can add up the digits. It's a way to do it. It's not terrible. It works out for these specific numbers that it is not so bad. But I'm a little leery, right? There's so many opportunities to make errors. Multiplying out 6 times 5 times 4 times 3 times 2, adding to it, trying to check whether these are prime, kind of a pain in the butt. Better way to do it. And again, I'm not going to go too crazy on the number properties right now, but think about what's going on here. So 6 factorial, multiple of 2, correct? Also multiple of 2. So this thing combined has to be multiple of 2. You could factor a 2 out of it if you'd like. So that can't be prime. What about this? Well, this is a multiple of 6. This is a multiple of 6, obviously. Factor out of 6 can't be prime. That's going to be true of everything in between. So I don't have to do all this stuff with the involved arithmetic. You can, not a terrible way. Again, especially if arithmetic is pretty slick, maybe not so bad. You'll get there. Slightly better. Again, very typical GMAT. There's bad ways, there's good ways, there's pretty good ways. Nice variety here. Once I recognize the property here, that I've got this thing, multiple of 2, add another 2 to it, still a multiple of 2. 6 factorial plus 3, got to be a multiple of 3. 6 factorial plus 4, got to be multiple of 4, and so on. There's no prime numbers here. There's no way for there to be. And that's it. Answer's A. All right. We are at the top of the hour. So thank you again to Stratus Admissions. Thank you so much for the donations, guys. Thank you so much for the support. Got some really nice notes from some of the folks there too. So thank you so much for supporting Ukraine. This is the end of hour number 9.